So, in this series, the solving optimization problem, this is our first lecture. So, in this lecture, we will learn how to differentiate the equation. So, in a previous series of lecture, we have seen various kind of optimization problem, but there we have not learned how to solve these optimization problem. Now, this is the time to learn how to solve this kind of optimization problem. Okay, let's start. So optimization problem we learn in when we learn in PCA, that is principal component analysis, logistic regressions, linear regression. So in every classifying or regression technique, we have see at the end of the day we have to calculate a optimization problem. Okay, so first write down this concept. We have seen that in every cases, in every regressions as well as classifications and also rest of the chapter we will see that at the end of the day we have to solve a optimization problem. Like previously we are seeing PCA, that is principal component analysis, logistic regression, linear regression. Okay, everywhere we have to solve a optimization problem, everywhere. Now the main thing is that how to solve this optimization problem. Okay, so this is the concept of differentiation. I think if you are a science student in undergraduate in an 11 12 standard, you are already learn about how to differentiate a function. Okay, I am not going to the detail, but I'm cover everything. I'm not going to the details of the differentiation, but I am just trying to cover everything. In machine learning, most most important is the in mathematics, mainly in calculus, the most important chapter is differentiation. Okay, so we will see that there are various kind of differentiation, that is called single value differentiation and also vector differentiation, or simply it is called the multi-valued differentiation. Okay, and when we are, we will see that to find a maximum or minimum of a equations, or a minimum of a equations, this concept differentiation is very useful. Most we will see it, we will see it, and we are also learned this concept in 11 and 12 standard. If you forget it, just don't bear with me. I will cover all the thing, all it in 99% cover. Again, I will repeat it, this concept. And in calculus, there have another chapters like integrations, differential equations, but it is not so useful as it is useful in differentiations. Differentiations in machine learning is the most fundamental concept. Okay, it is 99% places in machine learning uses the differentiation, but in integration, differential equation, these are not so useful. But if you see in another science field, that is fluid dynamics and another thing, it is also useful. But in in machine learning, in the world of machine learning, differentiation is the most important. That is, you can call the heart of the machine learning is differentiation. Okay, yes, okay. Now let's come fast concept one by one. Now let's start to the single value differentiation. Okay, let's start single value differentiation. So let our functions is y is equals to f of x. Okay, let let simple let our functions is y equals to f of x. So simple the equations is denoted by if y is equals to f of x, then our simple we denoted dy by dx is equals to simple dy by dx. Y means f of x. So simple it is like that f by dx is equals to y dash. Simple, just it is the notations of the differential equations. Dy by dx is equals to df by dx is called simply y dash or simply f dash. It is the notations, and mathematically we call it differentiation of y with respect to x. Okay, thus this is the notations of our differentiation or a single value differentiation. Just see this in geometry. Suppose let this is our axis. This axis is the independent axis x, and this axis is our dependent axis, that is y is at equals to y of f of x. Now simple, let's take a function like this kind of functions we have. Okay, now the concept of differentiation is that if we have a value x1 and another value x2, okay, and the function value of x1, the function value on x1 is equals to, here our function value is what, here our functional value is y1, and here our functional value is what, let's take our function value is what, here is y2, the functional value will be here. Now the difference of our independent variable is what, that is x2 minus x1, simply x2 minus x1, and the difference between our dependent variable is what, simple, right, just write now it x2 minus x1, and this thing is what, y2 minus y1. Simple, if we call the changes of our independent variable as well as dependent variable by using the notation delta, del simply, so our changes of dependent variable with respect to independent variable, that will be y2 minus y1 delta x. Just see it. Dy by dy. That is our height divided by our this thing. Simply, I don't know about the if you see this angle is theta. If you see this angle is theta, then y2 minus y1 divided by x2 minus y x1 is equals to what? Is equals to tan theta. Okay. Simple, just we are using the concept of tan theta here. Or intuitively this concept, using this concept differentiation, intuitively it is called at rate of rate of change of y, rate of change of y as x changes. Okay. Intuitively, if we call this concept rate of change of y as x changes. Okay. Means what? This means what? This means how much does y changes as x changes. This means what? How how much does y change as x change? Okay. This means as how much our independent variable changes when our dependent variable changes this much. This simple thing geometrically. Just think about the geometrically, then you simplify this concept. Now, this is simple tan theta geometrical concept. Now, coming to the geometrical part of the differentiation. Okay, what is that? How to relate these differentiations with geometry? Just to redraw this picture. This is our, and we are taking that our one value is here, that is called x1, and another value is here, that is we call x2. So simply our tan theta will be what? This is the tan theta, that is this actually this portion, if theta. Okay, actually this tan theta means this what? That is our hypotenuse. This, yeah, just see this triangle. In this triangle, the hypotenuse angle in the x-axis is actually tan theta. So tangent, simple. If now if we consider, write down the concept of geometrical concept, dy by dx. Just I am just writing this limit del x tends to 0, del y by del x. Okay, means what? Just see limit. Just don't be confused of this sign. This is simply limit concept. Limit means what? Here we am taking just distances x1 and x2. Now here using the limit, we are choosing the distance in such a way the distance is so this is the x2 is close to this one. Okay, when x2 is closest to x1, just the distance, just the distance is tends to 0. Okay, that's negligible simply. Okay, this means that when x2 tends to x1, this means, then what will be the hypotenuse? So hypotenuse length of the hypotenuse in this case will be what? Here, if this point move this way, then hypotenuse will be the tangent of this point x1. I am denoting it another using another color. This will be the tangent of this point. Okay. If this, if x2 moves towards x1, then the hypotenuse of this triangle, it will be a tangent of that point, that is x1, at that point of the x1. So if this hypotenuse, now if this hypotenuse make a angle theta, then our tan theta will be dy by dx. So just write down. So simply, if x2, if delta x, if delta x, that is our x2 minus x1 tends to 0, or if x2 moves towards x1, then tangent is the our hypotenuse. Tangent will be our hypotenuse in the in in the point what? In the point x1. Okay. So in this case, we call it the tan theta is equals to dy by dx at x equals to x1. Means x1, in the point of x1, our now differentiation will be tan theta. Okay. Or it will be written as x delta x tends to 0, then our del y by simply or equals to delta y by delta x. Simple. I think all the idea are now clear. If simply we are using the simply trigonometry here, geometrical concept, just taking the two different point of independent variable and just counting the distance and find its respective changes, how much this point changes with respect to, so changes of the independent variable with respect to independent variable. Okay, and just we have taken the closer and closer point of this point. So to denote this closure signs, we are using limit concept here, and this, when these distances of the independent variable tends to 0, then the rate of the change, we call it as a differentiation. Okay, don't be confused of this terminology, all these notations. Just we are denoting to understand what the geometrical mean actually. Just want try to see the thing geometrically. Okay, I think then it will be better visual, then you can visualize thing properly. Just don't be confused to use what is mathematics and how the term will be. Just think geometrically. Okay, now simple, what will get? Dy by dx means what? Means slope of the tangent. Simple, this one, slope of the tangent to the curve f of x if this curve is f of x, if we call this curve f of x, simple, this will be slope of the tangent to f of x. Mm, if we specify a point, this is our general case for all the point. This is the simple general questions of the all the point. If we using it specific to a specific point, then what will be? This means what? Slope of the tangent to f of x at point x is equals to x1. This simple. This here in this here we are using simple single point. Here we are using this. We are using the general point. So now differentiation. This concept differentiation. Okay, differentiation. This concept are arises in a late 1600. So late 1600s, near about late 1600, this concept are independently given by Newton and Leibniz. Okay. Newton and Leibniz both are given the same concept in independently. Sorry, LIP. Both are giving the same concept independently. Independent. So they are using this concept to describe this velocity, accelerations, gravity, etc. This kind of physical things. To describe these things, they are using the differentiation notation. Okay, I think all of you are know about this, so I am not going to the details of this. So simple. If we summarize this concept in single line, so differentiation mainly used in to use the to denote the rate of changes, to use the rate of changes. This concept differentiation mainly used to denote the concept of rate of changes. Now let's just simply discuss about the some cases. Okay, if we take if we see the tan function, okay, at least to what differentiation with tangent to the hypotenuse. Component differentiation means that is we learn it dy by dx is equals to simple tan theta. Okay, simple tan theta dy by dx tan theta. When our tan theta means of a particular point, if we consider a particular point of that point, the hypotenuse value, the hypotenuse, that is the angle of the hypotenuse of the x-axis, that is called the differentiation. That is called actually dy by dx. This one we have seen it. So if you see the geometrical perspective, tangent, just see the value of the tan theta, tangent and the with respect to x-axis, just see a value. If this is our x-axis and this is our y-axis, if we see this picture, tan theta means this tangent value. Tangent will be positive for when theta value lies between 0 to 90 degree. Okay, then it will be positive if 0 less than theta less than 90 degree, then only our tan theta is positive. If simple you just now you just using the tan x picture, what will be the how to look like tan x if we want to see this. So just here let it is our 90-degree point, it is our 0-degree point, then between 0 to 90 degree this value takes this kind of. I think all of you know about the plot tan theta, and in 90 degree there will value infinity does not exist tan theta infinity value. Then after that it will take this value like this kind of value. Okay, this kind of value it will. Sorry. I'm just this kind. It is in 90 degree they have not value. Sorry, this kind of equations it is. In 90 degree it will be taking the infinity dividing. Okay, this kind of thing. I think you are all know about this. Simply Google it, then you can easily find. Okay, so we will see that between 90 to if our theta's value between 0 to 90 degree, then it will only take the positive value. Otherwise, it will take it is a negative value. Okay, just see this. So now let's take one graph. Now let's take to just discuss this case one by one. How the graph like just if we see now just see this graph. If we see this type of graph, if we consider sample this point, then what will be the tangent value of this point? The tangent value of this point means what? This it is the parallel to the our x-axis. This is our x-axis. This is our y-axis. Simply this value will be parallel to the x-axis value, and this is called our tangent. Okay? In this point, this is our tangent, and it is simply take the value. And if you just see this graph, the minimum value will be exist here. There have no maximum value. Okay, and you see that in minimum value, our tangent will be what? Our tangent is parallel to the x-axis. Mean tan theta is what? Theta is simply here 0 degree. So simply here tan 0 degree means what? Tan 0 is means 0. So here tangent value will be 0. And if you see this kind, if you see this and our theta value, if our theta value like greater than 0 degree, means what? The angle between x-axis and this what? In positive directions. This one will be have theta, and now tan theta will be what? If our theta is greater than 90, less than 180, then our tan theta will be what? Tan theta will be negative. Just see this picture. Okay, then tan theta will be our negative. It is the now tangent. If our thetas lie between 0 to 90 degree, then our tan theta value will be positive. If theta value lies between 90 to 180 degree, then theta value will be between 90 to 180 degree, then theta value will be negative. Okay. Simple. If we consider here in minimum point, we see that our tangent value will parallel to the x-axis, that is will be 0. If we see this side of the plane, just see this side of the plane. If we just consider this side, if we just see this side of the plane and draw a tangent of this side, then the tan theta value will be what? Here it tan or positive, that is our here theta will be what? Here theta is simply lies between 0 to 90 degree. So our here positive slope is positive. Just see this side. If we see this side of the sloping value, here our theta will be what? Here theta will be greater than 90 degree. So in this side, our slope will be negative. Our slope will be negative. This side our slope is positive. This side our slope will be just geometrically. If you see this concept, geometrical perspective, this concept. Now, what will be the mathematical operations of the differentiation? Just simple. If you just don't remember it, I am suggesting please go to our 12th and 12th and 11th, 12th standard. Just pick up your 12th, 11th standard mathematics, but then you can easily find these kind of definitions, these kind of operations. If you forget it, just go there. You can easily find it. So simple differentiations of our x to the power n will be what? X to the power n into x to the power n minus 1. Differentiation of a constant will be what? 0 when c is equals to a constant. Differentiations of c of x to the power n will be what? Cn of x to the power n minus 1 d by dx of log of x will be what? Equals to 1 by x. Okay, this is the sample. Using basic algebra you can find this operation. Okay, I'm not going to the details of this, just you can easily find it. And one main concept, exponential of differentiation, is again exponential. This is the simple concept. And the differentiation is also a linear simple. If you using the differentiation of two function, simple, it independently it will differentiate each function. Simple differentiation is a linear operator. That is a linear operator. Okay. Now coming to the main concept of the differentiation, the world of machine learning, the world of artificial intelligence is nothing, just a chain rule. Now we are going to the, if you just see, if you just we will see the when we going to the deep learning chapter, we will see there just deep learning is simple nothing, Deep learning, or you simply call modern machine learning, is nothing, just using the concept of chain rule. Every this total computer science, this total complex software, everything is nothing. It's a simple uses of the chain rule. So now, what is the chain rule? Chain rule means if you want to composite, if you want to just consider the composite of functions. So composite of functions means what? Our functions of function. So if you use two functions here, f and g, and we are using g of x as the argument of f of x. Okay. So this means if we want to just differentiate this composite of the function, then what will be? Then what will be? So simply it will be f of, so just first we differentiate it, and what will be its argument? If the argument of f is g, just first differentiate with respect to it. Now going to the g of x function. Now what will be the now argument of g? It will x. Now differentiation by using stepwise. First, our what will be the outer function? Just see the outer function first. Our outer function is f, and what is will be its argument? Its argument is g. So we have to first differentiation f with respect to its argument g. Now going to its argument. What will be its argument? Its argument now g, and what will be its argument? And what will be the argument of g? Its argument is x. So df by dg is equal to dg by dx. Okay. Into simple. This is the now going to clear this concept taking an example. So just consider an example. Suppose let's take our f of x is equals to x square, and the g of x. Simple. Let's take a minus b, a minus b of x. Then what will be the f of g of x? Means what? Just simple write down this. F of g of x means what? A minus b. F of a minus bx. Now coming to this, f of x means x square, and now in the place of x square we are using a minus b x. Will be this. This will be now this the function. Now what will be the differentiation in this case? We know that d by of dx of x square means what? 2x. Just using this thing first. First we want to differentiation this df by dz. Okay, and just coming to this side, I think it will be clear for you. Okay, so first we are want to differentiation because g is the independent variable of this. So first we are going to count the dg by dx. So dg by dx means what? And simply it is minus b. Now coming to this part, df by dc. df by dg means what? df by dg. Now df, this function, if you just simply df by dg, here d by d of dg means what? A minus bx, and what will be now the f of g of x, a whole square. If we just call let a minus bx is equals to z, then this form will be transformed to what? d by dz of z square. So simply 2z into 2 into minus bx Now what will be a total differentiation now? Now what will be a totals? So simple multiplication of these two things. Multiplication of these two things. So now d of f of g of x is equals to what? D of x is equals to minus 2b of a minus bx. This is our final differentiation. Okay, this will be our final differentiation. I think all are this till now it is clear, all of you, what is the meaning of actual differentiation and how to play with differentiation using chain rule. Okay. Okay, in the next chapter we will see in the multi-value differentiation.